I'm Easton Miller. I would like to thank Jeannie, Bractlet, and Codesmith for giving me the opportunity to speak about Apache Kafka today. Let's not start with the what is Kafka, but the why Kafka came to be. In the year 2000, fresh off the heels of Y2K, the number of global internet users was 413 million people, a respectable 6.7% of the world. In 2016, that number grew to 3.4 billion. That is 52% of the world tip-tapping away on their phone screens. 3.4 billion people texting their grandmothers. That is more people than the populations of China, India, and the US combined, sending emails, watching videos, talking, reading, writing, and creating. More than that, there are on average 640,000 more users every day for the last 5 years. Let's put those numbers in the context of events. An event is any action or occurrence represented with data that can be quantified. That is trillions of events that need to be tracked, recorded, and interpreted into useful data daily. Enter Apache Kafka, an open source platform for interpreting, streaming, reading, writing, and connecting user data. Kafka is a distributed storage system accepting data from hundreds of sources concurrently and storing the data in real-time sequential order. Organizing event processing in this way allows for a scalable, fault-tolerant, and responsive network that can be utilized in a number of ways. Let's go over the many ways in which Kafka has changed the landscape of processing data. When designing an application, there weren't many options when it came to architecture. A monolithic application was the most common for a long time. One user base storing and pulling information from the same place. Let's use Netflix as an example. But let's use 2003 Netflix. Netflix is close to 1 million users at this point, but their data is relatively thin. Jack Black is on the upswing of his career, and let's be honest, he still is. The man is a force of kind comedy and authenticity. America is hot for Jack, and they're growing bored with Blockbuster, just like they grew bored with public libraries 10 years before. To sign up, the only data Netflix needs is a consumer name, address, and credit card number. And the user is able to log on to Netflix, select a movie, and watch it 2 days later. Regarding internal data, they need to know how many of each movie they have at their distribution centers, which distribution centers have the movie being requested, and where their rented DVDs are located. Databases made sense for this type of data. Jack Black was incredible in high fidelity, and Netflix was growing. Netflix now has 231 million users. Their service has shifted from shipping DVDs to streaming, and data needing to be processed is 1 million times what it was. Keeping track of data sets produced by hundreds of millions of users is complex, but we can simplify it. Netflix has built the Keystone data pipeline to handle these data sets. The Keystone data pipeline is a network of 36 Kafka clusters processing and tracking over 700 billion events per day. Some examples of these events include tracking error logs and user viewing activities, just to name a few. One of these data sets that is monitored is user preferences. Based off of the type of material the user consumed, data is sent to Netflix's Kafka clusters to be processed and then distributed to consumers, a process Netflix calls its recommendation engine. Cool word, but let's break that down into their individual components. The year is 2006. Netflix hit their 1 million subscriber mark 3 years ago, and they are still growing. Little does the world know that productivity is going to plummet next year in 2007, because that is the year that Netflix will introduce streaming to its platform. One smart cookie has an idea, though, and thinks to themselves, wow, it would sure be neat to be able to suggest to users what they might want to watch next. This engineer's idea was tabled, though, because Jack Black had just starred in Nacho Libre, Tenacious D and the Pick of Destiny, and The Holiday, all in the span of a year. Those were the only 3 movies America wanted to watch, so the big wigs at Netflix tabled the idea. Plus, Kafka wouldn't exist for another 5 years anyway. When this idea finally got picked up, Netflix realized to know what a user might want to watch, you have to know what the media the user has already watched. This type of user data can be translated through Kafka producers, which are nothing more than producers of curated data. These producers will take events and broadcast them to a topic. While we are separating the data into relevant topics, we are still talking about events, and the order in which these events happen are relevant. For instance, just last night, I watched Peter Jackson's King Kong starring Jack Black, as well as the severely underrated film Gulliver's Travels. Netflix could recommend a documentary on silverback gorillas after watching King Kong, or maybe even other films based off of books like Gulliver's Travels. However, Netflix knows that the day before that someone in Indiana watched School of Rock, the Jumanji reboot, and wrapped up the triple feature with The Holiday. So obviously Kafka's recommendation engine, Netflix suggested I watch The Holiday for the 15th time this month because Kate Winslet's chemistry with Jack is undeniable, and the movie didn't even need a dramatic boat crash. So at this point, Netflix has populated a suggestion based off of mine and others' viewing habits. But how do I receive this recommendation? This is done through the Consumer API. During this presentation, I've been watching the episode of Community where Jack Black cameos as Buddy on my second monitor. Netflix, as we speak, is calling to its recommendation engine and is sending my instance of Netflix the recommendation of what I should watch next. It seems to be the episode of The Office where Jack Black stars in a fake movie opposite Cloris Leachman in a performance ripe with tension as he wrestles with his love for her. The Kafka Consumer API gives my instance of Netflix the ability to subscribe to data streams from these Kafka topics. An architecture that supports a subscription system allows for faster API calls that aren't weighted down with unnecessary information. Let's take two data sets and show how effective this system is. Netflix has a topic for all the error logs its users have encountered and a topic for all the collections of common patterns of media consumption. Remember these patterns because we will come back to them later. There is no correlation between these data sets and they don't inform each other. Besides, the fact that a user can consume this data more efficiently, the consumer's needs are different when it comes to what data is relevant. Bryce in Seattle is at work analyzing error logs, so right now he doesn't need inspiration from an episode of Black Mirror. Meanwhile, I'm settling in for my 35th viewing of Bernie to study the lighting design and how it complements Jack's dramatic and intimate portrayal of a man who is pushed to the edge. I am not interested in Netflix's downstream issues in Toledo while I'm watching a movie. Thanks to Consumer API, I have all the information I need right now when I need it, and so does Bryce. Well, now we did swing right by a problem. This is a Kafka cluster. These topics or string of events live on a node. While we have made a solid stride in organizing our data, it's not like 231 million producers are going to be writing their precious data to just one node. If a topic was only accessible on one node, this limits you in a pretty significant way. It's not scalable, so how can we fix this problem so the world can know which Jack Black film to watch next? This is where partitioning comes in. Partitioning takes a single topic log and breaks it into multiple logs, which can live on different nodes in order to take advantage of the distributed system architecture that makes clusters so valuable. Sometimes you will still want to write to a specific topic, though. On the producer side, producers are able to either distribute their events evenly in a round-robin way across a set of partitions, or they can pass keys with the data so they are assigned to specific topics, preserving them in their order. Okay, so let's recap what we've covered so far. Jack Black is quickly proving that he can do it all from drama to comedy and everything in between, and it's only 2007. When it comes to collecting large amounts of data, though, and distributing it in effective ways, we have producer APIs, writing data to topics on Kafka clusters and breaking them up even further into partitions. Then we have our consumer APIs, which are subscribed to these data streams and receive data that is relevant to them. But there are two more APIs that make up Netflix's architecture that allow them to service 231 million users. It is true that producer is writing specific data to a topic in the interest of being more organized, and the consumer is taking that data in an equally specific way. But in 2003, Netflix doesn't have much data to organize, and that what data Netflix does have is simple enough to be translated and adapted into different use cases. But Netflix 2016 has a bonkers amount of data streaming through these clusters. The Stream API is the next part of the puzzle. It consumes these data streams from various topics and processes and transforms the information and data or events as necessary. Let's say you're logging onto Netflix for the first time at the age of 75 because your 45-year-old son just gifted you a plasma screen TV. You spent your life in the coal mines of Pennsylvania, and you're not a nostalgic person, but Netflix knows that you live in Pennsylvania and you're in your later years. It can guess that you probably heard of Jan Lewin, the Ponzi scheming polka king of Pennsylvania. And guess what? You have. Trying to support your kids in a dying industry while battling chronic health issues from the mine made the polka music of Jan Lewin a sweet escape from the cold, dark earth. You are shocked when Netflix suggests the 2017 film, The Polka King, starring Jack Black. Maybe your soft son who moved to the city when he was 19 isn't so bad after all. To simplify this working class scenario, the Streams API consumed all this information and using an algorithm processed the information to populate a topic that is subscribed to by consumers. Before you know it, you're enthralled by the character growth of a panda trying to find his place in the world over 3 installments, the 4th of which is coming out next year in 2024. You hope to God you make it another year so you can see it. So you have data being written, processed, and then read in reliable and efficient ways through Apache Kafka. The fact of the matter is Kafka can't do it all, and it is not necessarily the best choice for all processes that a developer may need to implement. The Connect API is what allows Kafka to employ other services to make the scalable distributed system even more efficient. While Kafka has the ability to persist data on bare metal or collect data dynamically from producers and send them to consumers, there are some things that other technologies can just do better. In this scenario, the year is 2014, and a Netflix engineer is working on a presentation to pitch removing all movies from Netflix streaming, except for hosting the works of Jack Black. The engineer needs to search a robust collection of data to prove that Netflix's users don't care about anything but Jack. This is obvious, but they want to back it up with real data. Netflix uses a tool called Elasticsearch and connects to it using Kafka's Connect API. Netflix uses Elasticsearch to cull through data and aggregate information with queries in a fast and cost-effective way. While this sounds like something Kafka Streaming's API can take care of, Elasticsearch can be considered the Kafka of search and analytics when it comes to enormous and complex data sets. Unfortunately, dark money from Hollywood led to the engineer being fired and never able to give their presentation, but they were still able to search through massive amounts of data that would have cost a pretty penny had it not been for Connect API Kafka provides. So that wraps up the basic architecture of Kafka cluster. While we didn't cover the entirety of Keystone Data Pipeline, this is a foundation upon which Apache Kafka is implemented when large amounts of data streaming and processing is necessary. I did want to cover one last thing that wasn't explicitly said. Everything we have been over so far leads to the fact that Kafka is highly scalable. All these partitions we discussed are replicable and manageable. The clusters are self-managed in a similar way to Kubernetes through Kafka's Zookeeper, which acts as a control plane of sorts for making sure the clusters are healthy. With around 80% of the top 100 companies using Kafka, its usefulness really speaks for itself. There is so much more to Kafka. One can liken it to the soul of Jack Black: persistent, forgiving, highly distributed, and a lovely beard that is only getting better with age. In review, users will write to the cluster with the producer API, process the information stored in topics with the Streams API, load balance and distribute with partitions so that consumer APIs have access to fast and reliable data, and the entire system can be bolstered by other useful technologies through the Connect API, further increasing Kafka's usefulness. Here are my works cited. This has been Apache Kafka. Here's my LinkedIn and GitHub. If you have any questions for me, please feel free to reach out.